Many database management systems, DBMSs, have failure recovery systems that leave the database in a consistent state when unforeseen events, such as power outages or system failures, occur. Database management systems that provide transactional integrity allow establishing logical units of work, LUWs. Logical units of work correspond to nothing less than the concept of database transactions. Basically, an LUW is a set of database operations, all or none of which must be executed. That is to say, it's not possible that within an LUW some operations are executed and others are not. This ensures the integrity of the database. In the example, you can see an LUW consisting of 4 operations on the database, which could be insertions, updates, or deletions. Let's suppose that the first 2 were performed successfully, but before executing the third one, the system fails. Since the LUW was not completed, the 2 operations that were completed will have to be undone. Otherwise, as logical units of work define the consistent states of the database at a logical level, the database would be inconsistent. And in this case, the DBMS performs a so-called rollback to recover, keeping the last consistent state of the database. The commit command determines the end of an LUW. Thus, an LUW is defined by the operations performed between 2 commits. If the system fails where it's indicated, the 2 operations performed after the last commit, which are the operations pending commit, are undone by the automatic rollback, performed by the DBMS when it recovers from the failure. That is to say, since not all the operations that make up the LUW have been performed, those that have been partially performed are undone or reversed. Transactions and procedures are the Genexus objects created to update the information in the database. For this reason, Genexus writes the commit command when it generates the programs in the language that has been defined. Where? In the transaction object, at the end of each instance, immediately before the rules with after complete trigger event. In other words, after the header and lines have been handled. In the procedure object, at the end of the source. And business components, which are created from transactions, do not include commit because they can be used in any object. And it'll be up to the developer to determine where to commit. We'll see this next. The user adjusts the header and lines and presses confirm. On the server, the rules and formulas are executed according to the evaluation tree for the first level, and then the rules conditioned to the before validate event are triggered. After the header information is validated, the rules conditioned to the after validate events, and, depending on the mode, those conditioned to before insert, before update, or before delete are triggered. After that, the header is saved, and the rules that were conditioned to after insert, after update, or after delete are triggered, depending on the mode. Then, for each line, the rules are executed according to the evaluation tree. Rules with a before validate trigger event are executed at the line level. The line is validated, if it's considered satisfactory. Rules with after validate trigger event or, depending on the mode, before insert, before update, or before delete are executed. The record corresponding to the line is inserted, modified, or deleted in the database. And rules with after insert, after update, or after delete trigger event are executed, depending on the mode of the line. After completing the last line, the rules that have after level of a second level attribute as a triggering event are executed. If there's another parallel level, the same is repeated for that other level. When the last level is completed, the rules conditioned to the before complete event are triggered. After this, Genexus places the commit command automatically. Therefore, the commit is executed. That is to say, the header and line information is committed. Next, the rules that were conditioned to the after complete event are triggered. Suppose the user wants to enter 3 invoices into the system. He or she enters the first one, then the second one, and when he confirms the third one, let's suppose that when the program is processing the third line, after having saved it, the system crashes, and the database has to be started again. What state will the database be in? Since the DBMS will perform a rollback, it'll undo all operations that have not been committed. In this case, the records corresponding to the header and the 3 lines of invoice 3 will be deleted. Note that if the automatic commit of the invoice transaction had been disabled, property commit on exit equals no, none of the inserted records, neither those of invoice 1 nor those of invoice 2, and certainly not those of invoice 3, will remain in the database. In this case, all the operations will make up an LUW, but if the default value for the commit on exit property is yes, each header with its lines will make up a different LUW. For transactions, setting this property to yes is recommended. In every procedure that accesses the database, Genexus will automatically add a commit, unless otherwise indicated through the commit on exit property. Since procedures are used for other things besides updating the database, for example, to list information or perform calculations, or simply query the database, Genexus will automatically insert the commit command in the generated program if it understands that the procedure is trying to update the database. Otherwise, it doesn't add it, regardless of the value of the commit on exit property. In this case, where the new command is being used to insert a category and the for each is being used to update the category ID attribute of the table associated with the attraction transaction, since the commit on exit property is set to yes, Genexus will automatically write the commit in the generated program at the end of the code. This means that if after having inserted the new category in the category table, and when modifying the third Beijing monument by changing the category to the new one, the system fails. None of the previous changes, neither the new category nor the changes in the 2 previous monuments, will remain in the database. All the operations of this procedure will be part of the same LUW. Where does this LUW start? It'll depend on when the last commit was made. If a commit was made after the last operation on the database before invoking this procedure, then the LUW starts with the new of this procedure. Otherwise, this entire code will be part of an LUW that started earlier. Where? At the point immediately following the previous commit. Where does the LUW end? If the commit on exit property is set to yes, it finishes at the end of the procedure. Otherwise, it ends where the next commit is found, in the one that called this procedure. We'll have to see what follows its invocation. Genexus realizes that it has to access the database within a procedure when using the new command, or for each to update or delete. In these cases, it adds the implicit commit. Otherwise, it doesn't understand that there's a database access, and that's why the following is done in a procedure. Or, even if instead of .save, we do .insert, .update, or .insert or update, it doesn't add the commit. Genexus doesn't realize that we want to do an insert on the database, even using the insert method, so we have to write the commit command explicitly. As we've just said, if within the procedure code there's a new for each that updates, deletes, in any of these cases, it wouldn't be necessary to explicitly write the commit. If we only have this code in our procedure, we'll have to add it explicitly. In the example, we saw Genexus automatically place a commit at the end. But if we wanted the recording of the category to be part of an LUW and the recordings of the attractions to be part of another one, so that if the system failed before finishing the modification of the attractions, the category was entered, but the attractions were not, how would we do it? We would use a commit. We'll have to write a commit after having inserted the category, and another one after having inserted all the attractions. The latter can be avoided if we have the commit on exit property enabled. Anyway, it seems a good practice to write it explicitly, in case more operations are added later to the source of the procedure, which should be in another LUW. If we need to invoke from a transaction A, a procedure B that performs operations on the database, so that the updates of the transaction header record and all the lines, as well as all the records of the procedure, make up a single LUW, and therefore, if the system crashes before completing everything, all the changes are undone, what should we program? There are several ways to do this. One option is to follow these steps. 1. Invoke the procedure at some point prior to the automatic commit. For example, on before complete. And 2. Disable the automatic commit of the procedure. In this way, the procedure will be invoked after all the records have been saved, the one corresponding to the header and those corresponding to the lines, having already triggered all the rules conditioned to after-level events. In other words, the procedure will be called right before the commit. The procedure will perform all its database record updates, and since we've disabled its commit, if the developer did not explicitly include this command within the code, the LUW will not be closed. Once the execution of the procedure code is finished, it returns to the caller, to the statement following the invocation. This is where the commit will be found. Another option is to follow these steps. 1. It doesn't matter when the procedure is invoked, as long as it's after all the records, header and lines, of the transaction have been saved, even after where the commit would go. For example, on after complete. 2. As long as the automatic commit of the transaction is disabled and the automatic commit of the procedure is kept. By invoking the procedure at this point, we're sure that all header and line records will have been recorded. Then, the procedure will perform its database record updates and commit, thus committing all records, its own and those of the transaction. These are only two of the many possible options. The selected one will depend on the logic you're trying to implement. Usually, you'll be concerned about the time the procedure is invoked. There is a customer transaction that records customers and their booked trips. Suppose we don't want to use the database auto-numbering strategy, but rather, we want to have our own internal table in the database that records the last number given to each entity to number its identifier. To this end, we create a numbering transaction, whose numbering code identifier attribute records the name of the entity in question. For example, customer, trip, invoice, category, attraction, and so on, and its numbering last ID attribute, the last number given for that entity. Next, we'll program a procedure, getNextNumber, which will obtain the next number to be assigned to the identifier of the calling entity. We'll examine the code in a moment. For example, from the customer transaction, when the user wants to enter a new customer, he'll leave the customer ID field empty on the screen. And when he leaves the field, moving to the next field, customer name, the transaction will know that he's trying to enter a new record. It'll be in INS insert mode. Since the customer ID attribute is not auto-numbered, we'll have to invoke the getNextNumber procedure to obtain the number to assign to customer ID. We must send who we are as a parameter to the procedure. That is to say, in this case, customer, so that the procedure looks for the last number given to a customer in the numbering table. Let's see in detail what the created procedure does. First of all, in the rules, we declare two parameters, one input and one output parameter. The input parameter will be used to know what we want to number, such as a customer, a trip, an invoice, and so on. This variable will be of character type. And as output, we declare the NextNumber variable of numeric type, which will return the value we're interested in. Going back to the source, the table of the numbering transaction will be run through. With where, we indicate that we want to retrieve the record in which numbering code has the same value as the variable that we sent in a parameter. In this case, customers. If it finds it, one will be added to the numbering last ID attribute, and that value will be assigned to the next number variable. Then, to the numbering last ID attribute, we assign the value of next number. If no record is found in which numbering code has the value of the variable we sent to it, we'll create a record in the database using the new command. Here, numbering code will have the value of the variable sent in a parameter, for example, invoice. Next, we assign to the next number variable the value 1. And to the numbering last ID attribute, we assign the value of next number because, as it's a new record in this table, we'll start with this value. If we invoked this procedure using the assignment rule without a trigger event, for example, if insert, the procedure will be triggered. Once, as soon as the user leaves the customer ID field empty on the screen and leaves the field, and a second time when the user confirms and the rules are triggered again in order on the server. Let's imagine that the last customer ID is 5. The procedure will be executed by updating the corresponding numbering table record to 6 and immediately displaying the number 6 to the user on the screen. But what happens if the user changes his mind and never presses confirm, but cancels? Number 6 will have been lost. Even if the user does confirm, the procedure will be run again, and the number assigned to the customer will be 7. So the number 6 will also be lost. How do we solve this situation? By conditioning the invocation of the procedure to a trigger event. In this way, the assignment rule will not be triggered on the client while the user is working on the screen. When is the right time? The last possible moment is before insert of the header. Why? Because after that moment, the value we assign to any of its attributes will have no effect, since the record will have already been saved. The getNextNumber procedure modifies a record in the numbering table, or inserts one if it didn't exist. By default, it'll place an automatic commit at the end. In this way, if after returning to the transaction, suppose that the customer is inserted in its table, and when the third trip is being inserted, the system fails. The records associated with the customer will not be recorded when the system is restored. But the number will be lost, because it's already been committed. For all the operations performed through a transaction and procedure to remain within the same LUW, in this case, it'll be enough to not commit on exit in the procedure, and that the commit of everything is done by the transaction. A single LUW cannot be made up between transactions. If, from a transaction, a procedure is invoked that invokes another procedure, all with commit disabled except the last one, or its commit can also be disabled and have the transaction commit when the control is returned. It'll commit the records of the transaction and of all the procedures. However, if transaction A calls another transaction B, the commit of the second one, B, will not commit the records handled by the first one, A. They are independent commit operations. So if we disable the commit of A and call B, which does commit, the records of A will not be committed by anyone. So, how do we get the header and lines of transaction A to be entered, transaction B to be called to enter somewhat related information, and all these operations to make up a single LUW? From work with categories, we want that by pressing Insert, the users offer the possibility to enter a new category, and right afterwards, an attraction of that category. Because we don't want to leave categories inserted without related attractions. To do so, from the category transaction, it'll be enough to invoke the transaction attraction on after insert, so that category ID already has the correct auto-numbered value given by the database, and to declare an attraction that it'll receive a parameter. This way, when we enter a category, it'll take us to the attraction transaction to enter an attraction. The category that we've just sent in a parameter will have been selected. But what happens if the system fails immediately after attraction has made its commit? Will this commit have also committed the category record that has already been inserted? The answer is no, because of what we saw before. We need the insertion of a category and then of an attraction to make up the same LUW, and the final commit to include both records. How do we go about it? We'll look at two of the many options available. One solution will be for the Insert button of the Work With to invoke a web panel, which is an object with an interface where developers can freely program behavior. There we insert two variables, category and attraction, in its form. They'll be business components of category and attraction respectively. We only need the user to insert the name of the category he wants to create, and the name of the attraction of that category. Doing so, and pressing confirm, will trigger the associated event, which we've programmed as shown in the event screen. For this example, note that the country ID and attraction ID attributes of the country and attraction transactions respectively have the auto-number property set to true. First, we try to insert the business component of category. If it fails, for example, if the user left the category name empty on the screen and the transaction has an error rule to prevent that, we show in the error viewer control the messages generated by the business component. In that example, the error message is triggered twice, once on the client side when we leave the field empty, and another time when we confirm on the server side. Both cases yield the same result. We call these types of rules idempotent. If we enter all the data correctly, then to the business component variable of attraction, we assign as category the one we've just inserted, and try to save. We show the messages generated, and then, if the operation was successful, we commit, after which both records will be committed. If the operation failed, then note that we have the rollback command to undo the insertion of the category record that had been successfully inserted. A second option to solve the same requirement is to use a dynamic transaction instead of the web panel. Remember that dynamic transactions are those that do not generate a physical table. The queried data is obtained at runtime. They are defined by configuring the following transaction properties: data provider, set to true, and used to set to retrieve data. By setting the data provider to true, a data provider object will be automatically created. And by setting used to retrieve data, Genexus will understand that it will not have to create the table associated with the transaction, because the data provider will declare where to obtain the data from. In the example, we create the dynamic transaction attraction category, whose information will be taken from the attraction table, knowing that each attraction has a category. It'll be like an attraction view. When the user wants to insert an attraction in this transaction, he'll be allowed to enter the attraction data as well as the category data. In the insert event, we use category business component of category and attraction business component of attraction, and copy to its members the values that the user specified in the attributes of the dynamic transaction through its form. If the category doesn't exist, it's created before inserting the attraction. Otherwise, its name can be updated. Next, the attraction is inserted with the category. If we leave the commit on exit property of the transaction with its default value, yes, after the insert event is executed, since it's a single level transaction, the commit will be made, which will have an effect on the two records inserted through the business components.